and we want to get our products into the web, products into the hands of people. What do? There's so much advancements in AI NLP that we have so many awesome products right now with us, and not products, but the strength, the power of these AI models are reaching intense heights, and then everybody's looking to integrate these AI interfaces with the products. They want to utilize this potential. They want to harness this potential. They want to tap into this AI revolution. If you want to do that, join me right now. Let's talk about LLM Inference. And for our first video, let's take a look at the services provided by Databricks, and it's called MosaicML Inference. There's this good article about it, and since it is available for experimentation and uses with a enterprise tier and with a basically we need to get access to it before we can inference it, and getting access to it is much easier if you are a company rather than a single solo developer like me. So with that being said, let's go. What I'm trying to say is we are going to look at the MosaicML Inference, and there's this good article about it which will give us a understanding of it, high level view, the eagle side view of it, and it's not that hard either. So let's get started. So this is what I was talking about. You have a you have an in-house product, and there are some functions, there are some project ideas that your team has come up with. Now you need to call APIs. There are several methods for which you can do that with. One option would be to use the big companies' APIs and do an API call on them, like OpenAI's GPT Stream, and OpenAI, not just GPT but OpenAI as a whole, Anthropic, and many more, Cohere, and many more. Or you could self-host your open source LLMs. You could rent a GPU. You could download the transformers or any other models, the diffusion models, into your system, into the GPU, make an API out of it and host it. Do the whole 9 yards. Dockerize it, containerize it, make the API, buy a GPU or rent a GPU and then host it, and then make an API call on it. Do the CI/CD pipeline, the whole 9 yards. Or what you could use the managed services, and this is what is the topic of today's video: managed AI services, like almost an AI as a service. So you get the idea now, right? We have a product, a company that wants to interact with APIs, and how do we do it? Introducing MosaicML Inference, and we'll go through an example of how this is possible and achievable. So let's go. Llama 2 70B, we will go and check out, we will experiment with Llama 2 70B chat model in this video. We know that Llama's 27B chat is a leading AI model for text completion, comparable with ChatGPT in terms of quality. It was outsourced and open sourced by Meta, and it is one of the most leading LLM in the open source and the overall LLM benchmark in the market right now. Today's organizations can leverage this state-of-the-art model through a simple API with enterprise-grade reliability. So reliability, enterprise-grade reliability, that means the system is not prone to failure or breakdowns. Security, like that your data is your data and it's not lost or stolen or hacked or leaked or utilized in any means possible. And performance, like the speed, the latency, the throughput, the accuracy, the optimization, the performance, by using MosaicML Inference and MLflow AI gateway. Yeah, along with MosaicML Inference, we have another surprise inference platform and framework, that's MLflow AI gateway. Both of these are top tier companies, so you can bet your money on it. For some tasks, not all of it. Llama 270B chat is available via MosaicML Inference. To get started, sign up and check out the Inference product page. You can. So this is what I was talking about in my earlier ramblings. Get started. You can get started. You need to fill up this form and then submit, and they will contact you and get started. I have done that, but I haven't got it yet, but soon enough, hopefully. MosaicML, so these are the doc products, models, blog development, the documentation, everything is there. On July 18th, almost 1 year from now, before now, Meta published Llama 270B chat, a 70 billion parameter language model pre-trained on 2 trillion tokens of text with a context length of 4096. Remember this hyperparameter, this parameter metric, the token length. This will be important for whenever you're dealing with text and dealing with real life products, because the model is not infinitely long. You cannot use it, has its limitations. Every model has its limitations. It's not infinite like every other technology. Most LLMs have a token size, and if you be aware of that, if you be aware of that, you could modify and align and just be well prepared when developing software systems. It's comparable to quality close proprietary models such as OpenAI's ChatGPT and Google Palm's Bison. Meta made the model publicly available with a commercially permissive license that enables the broader ML. It has a commercially permissive license. That's great. That means the broader ML community can use this work, learn from it, and build on top of it and leverage it for commercial use cases. So they have given the license for it. So any company can build up on Llama 270B. You can fine tune it, you can apply parameter efficient fine tuning and instruct fine tune it for your own purpose and build great systems with it. However, enterprise development of Llama 270B chat is challenging. So here we come to the crux of this video, the main part, the most thing that this video revolves around. However, enterprise deployment of Llama 270B chat is challenging and costly. It is challenging because of the technical requirements and the tinkering around you have to do with it, and it's costly because it's related with GPUs. LLMs run on GPUs, and GPUs are a commodity right now. It is extremely expensive. Achieving adequate reliability, latency, and throughput for commercial grade applications requires state-of-the-art GPUs and sophisticated system and ML optimization. That's why we're making Llama 270B chat available on the MosaicML Inference service. Customers who use the service can start experimenting with Llama 270B chat within minutes, benefiting from enterprise grade reliability, security, and performance while paying for users only on a per token basis. So this is a pay-as-you-go method and is applied on a per token basis, so it should be fairly competitive with the OpenAI and Google models and should be cheap. Plus, when you look at all the things that we have to manually do and the manpower required for it, it may be comparable, the prices. It automates people. Not that I'm saying is like the automation should be selected over human services, what I'm trying to say, what it came out and what is shaping up to be is like that. So maybe with automation we can have new jobs and expand more the limits and the consciousness of our horizons, of our mind, and of our humanity as a whole. So, deploying this model and interacting with it is as simple as this. Let's go. So querying Llama 270B chat with MosaicML Inference API. So invoking Llama 270B chat text completion with MosaicML Inference is as easy as importing a Python module and calling an API. So this is given in Python. So you just import the predict model from the MCLI SDK. This hosting can be models hosted on MosaicML hosting. This can be done once we're inside the system. I'm not yet able to access inside the system. You have to join the waiting list, and you can use the URL, the function, the prompt. This will be your business specific, any prompt that caters to your business, logistics, ecology, HR, business, cybersecurity, perhaps security, perhaps banking. What else? Yeah, all those stuff. As much domain as you can think of. Then you can just predict it, use the URL, the inputs, the parameters. You can just predict it and you get the response. Airlines, air services, anything. You can further customize your outputs to the following parameters: the maximum number of tokens, the temperature, the top pay, and top K. You all know about this. I'm happy to dive deep into this metrics in another video. Same can be done through MLflow AI Gateway. This is from Databricks and is a highly scalable, enterprise-grade, applicable API gateway that enables organizations to manage their LLMs for experimentation. You can have LLM credentials and stored and managed properly. The deployments exposes standardized interfaces for common tasks such as text completions and embedding, and provides cost management guardrails too. Guardrails and instruction fine-tuning. What a combo. So you can just make a function, call it, and get a response. Same as MosaicML Inference. Now whichever you prefer better, you can go with it. And there are some other blog posts from Databricks too to leverage retrieval augmented generation. So now let's talk a little bit about serving. So one serving is like, how would you define it? So when you rent a GPU, sometimes it may break down, sometimes it may be offline, sometimes the volume would be high, sometimes the volume would be low. So would you keep a same GPU for all throughout your process, or would you like to efficiently optimize your GPU processes? Meaning as for example, the traffic is not set to high volume all the time. There must be some time at the day when you need more GPU than others. Sometimes there would be times where they maybe not used at all. Sometimes when it could be used sometimes it may break down, sometimes it may need repairing, sometimes it may need updating, so all of this come under so it would be good if we had a serving and like a way to make sure that it's properly functioning. So that's the main component of the deployment service that we will talk about in this part of the video. that is highlighting various reliability and security features such as auto restarts, rate limiting, and authentication. You also need to authenticate. You don't want anybody to get access to your system. So there are 3 models in this Llama v2 family with parameter size ranging from 14 GB to 140 GB in floor 16 precision. Llama 2 7 billion, Llama 2 13 billion, and Llama 2 70 billion. Each of these have different inference hardware requirements for serving. For example, 7B models can easily fit on a single NVIDIA A10 GPU 24 GB memory or NVIDIA A100 GPU 40 GB memory, while 70 billion doesn't in either float 16 or even 8 precision. Even if you quantize it, it still needs more memory than 40 GPU because of its 7 billion parameter. For the 7 billion parameter model Llama 2 70B chat, it is necessary to distribute the workload across multiple GPUs. So there are other processes which we will discuss more in the coming videos that will help us talk about this one, distributing the workload across multiple GPUs. However, multi-GPU serving is complicated. It's not as straightforward as it may seem. There will be data parallelization, model parallelization, tensor parallelization, and many other stuff. And naively serving without optimization is very expensive and it can be very slow. So the MosaicML platform comes, and other platforms comes with a service that provides reliability and security features such as auto restart, rate limiting, and authentication. Our deployment of the 70B model is served with multiple replicas for redundancy with built-in auto restarts to handle failure recovery. If for example when there are CUDA out of memories and a single replica goes down, the load balancer will route requests to another available replicas. The deployment itself is monitored to detect failures all the time. All the while the service is in production, the deployment itself is monitored to detect failures. Each replica implements rate limiting to ensure fairness among different clients. To ensure fairness among different clients and to avoid overloading the service. Moreover, we are working to have replicas deployed across multiple regions to ensure high reliability. So they are also using the strategies applied by many other cloud service providers like AWS to deploy across multiple regions to ensure high availability, and that's a very smart move. Now let's talk about security, because that's a major concern in the world that we live in right now. Cybersecurity is a major issue. People are trying to hack you all the time. They come up with scams. They want to take your money. They want extort you, blackmail you. That's inside the very company world. People from outside of the country, they want to hack into your system. Governments are highly aware of this, and they have the best interests to provide security and system for the national security and stuff. So security is a very important concern in everything we do, because there are bad actors in the world and they are malignant, and if we go down to the psychology of it, it's very I would love to go in depth about it. Carl Jung has described most of it in the collective consciousness, collective unconscious, and how the mind works, and it's also in evolutionary patterns like genes. Like we are animals at the end of the day, and this has transcended its form, and now it's in the cybersecurity level threat. So MosaicML Inference platform is designed to maintain data privacy. User queries and responses generated by the model are not logged. The user queries that are input into the system and the responses model generated by the system are not logged. So that means nobody can hack into it and extract sensitive information. The platform does not record or log any data provided by the user or generated by the model as a response to user prompts. it only records non-identifiable operational system metrics. Non-identifiable and operational system metric, but you need to keep track of something, right? How to measure it, to evaluate, to have the scientific process involved in it. But the personal identifier information is gone. That's a very good thing. Performance. Okay. Llama 2 and this are most of the current LLMs currently are based on transform models, and they can be optimized, and this is what it makes it possible to serve these large language models efficiently in MosaicML Inference and MLflow gateway. For now, for this one, they include a number of optimizations, including tensor parallelism, KV cache techniques, continuous batching, and other efficient methods. Some of the optimization we employ include tensor parallel. A 70 billion parameter model such as Llama 2 70B requires either 114 GV or requires to store the weights in the GPU memory. So let me go back again. Tensor parallel. A 70 billion parameter such as Llama 2 70B chat requires either 140 GB in float 16 or half 70 GB gigabytes of memory in int 8 just to store the weights in the GPU memory. So it's a very heavy model. And then you need to store the weights, the parameters, the KV, the optimizers and everything, the memory. To address this constraint, they have used a tensor parallel mechanism to fit the model into multiple memories of multiple GPUs. So memory sharing the model across multiple GPUs. A KV cache memory management and quantization. So we know transformer model works based on the attention model, and the attention is model is based around the attention layer is focused on is built using the key value query key value pairs. And so this is, if you know about the query key value, this method will be more understandable and will come across more easily. But if you don't, then you could go back and look at query key value and how the attention system works in transformers. So in autoregressive token generation, that means the model autoregressive, like it generates continuously. That's the basis for decoder based large language models. Pass key value. In this type of auto-regressive token generation, past key value pairs from the attention layers are cached. The past key value from the attention layers are cached. It's not necessary to recompute them at every step. The size of the KV cache can be significant depending on the number of sequences processed at a time. The size of the KV cache can be significant depending on the number of sequences processed at a time and the length of the sequences. Moreover, during each iteration of the next token generation, new KV items are added to the existing cache, making it bigger as new tokens are generated. So tokens are generated and the KV caches are being upgraded, uploaded, like filled up, and this just continuously incrementally increases the memory space of the processing unit that we're working on. Therefore, effective memory management that keeps the KV cache size small is critical for good inference performance. Therefore, effective memory management that keeps the KV cache size small is critical for good performance of the inference. Continuous batching. Batching, that is processing multiple requests simultaneously, is essential for efficient realization of GPU compute. However, requests from different clients do not arrive at the same time to form a batch. MosaicML Inference server supports adding requests to the server as they arrive and returning them as they get processed. This technique, known as continuous batching, optimizes GPU usage with minimal impact on request latency. So multiple inputs could be coming and you need to provide multiple outputs at the same time. But however, the thing that's how it's designed to have an efficient flow. But however, like all of the text generations and all of the requests will not be of the same length. Some might finish early, some might finish later, some might need to generate a long text, some might because early and they finish early and later because they may have to generate more text sometimes generate less, and they might not even come at the same time. So for this process, like continuous batching is a research and like optimization technique that's been used in most, and this is being used here too, and this is one of the optimization that makes the LLM inferencing faster and best increases the latency and throughput. Streaming of output tokens. Output token streaming enables incremental rendering of output tokens to the end user as tokens are generated. You know, if you've been working with LLMs, you know that sometimes when you just print or trying to get output from a model, you have to wait for 5 minutes and then only get the complete text generation and a bulk final text at the end. You need to wait 5 minutes for it, or maybe for 3, 2, 1, 30 seconds, depending upon your hardware size and demand. But what if it comes as it's being streamed, so that you don't have to wait and it's easier for the eyes to read? And this is good for the user experience for chat and similar use cases that delivers enhanced interactivity when generating long output sequences. Designing effective prompts. Llama, we've already talked about this in the video in the earlier part, and so this helps us keep track of the 409 token. This is the maximum length for this model. The 409.6 token corresponds to about 3,000 words. Sometimes they are whole word. This depends upon the encoding design used in the pre-training and the AI LLM architecture. Sometimes it may be byte pair encoding, sometimes it may be other pair of encodings. What it means is, if you ask to summarize the 40925 tokens using and keep in mind there are 4096 tokens, you will only have one token for the model to respond with. Okay, so you can keep track and check how many tokens of message you have. You can use Llama 2's tokenizer, which is available to experiment with Llama token and JS. Now let's take a look at the retrieval augmented generation. This is a new field in AI, and we will go into it further in the next video. But if you are familiar with RAGs and if you want to use RAGs, you can also do it. You can use the endpoint URL. You can decide the system prompt of how you. Okay, so say you want to answer a domain specific question based on a set of documents. We have a set of documents and you want to ask a domain specific based questions. A popular method to use is retrieval augmented generation. With RAG, you first retrieve a set of relevant documents from a larger document store based on the user query. So based on the user query, it goes out and extracts and retrieves a set of relevant documents from a larger document store. And this will be passed along the LLM as context to help it answer the query. This method allows the LLM to draw on knowledge it may not have seen before, and it helps to reduce hallucination. For this simple example, they have used not a full vector database or document database, but just a hand-coded set of relevant models. So you need to be aware of 3 things when you're doing it: a set of documents, a user message that comes from the user asking the domain specific questions, and the system prompt, like how do you want the user prompt and the document generated from the retrieval to interact and give you the knowledge. And so that's the system prompt. You can specify and them. You can have the endpoint URL, you can have the functions, the temperature, the parameters. You can generate a function. You can have a retrieve documents function that can retrieve documents from a vector database. And you can have a RAG, construct a RAG input that uses the user query system prompt to create a user that can be fed to the RAG. And likewise, like this, you can have interact with the documents. This is just a basic simple example because it is using just a simple data set of JSON values. You could do it with larger documents, and there are plenty of tutorials out there to let us know how to do it. We'll also explore that in the future videos. And this is a license for the video, and this has been a dive into the MosaicML Inference and just LLM Inference engine, and what you need to be aware of when you are working with LLMs, and when you want to productionize it. This could be used for DevOps people, the AI product managers, the AI inference engineers, and everybody in general. So I hope you have a good night. Stay safe. Take care. See you next time. Bye bye.